The direction of the wind is determined by various factors, including the friction or lack of friction the Earth's surface places on it. Wind going over the body of a water can change direction due to a decrease in the amount of friction it experiences. Pretty generally speaking, warm air from the equator rises, moves towards the poles, falls, and then returns to the equator, helping create a wind pattern. Cells of wind patterns are present all over the globe and include trade winds, which helped European settlers in America. The direction of the wind is measured according to a number of degrees from true north, or 360 degrees on a compass, and is described according to the direction it originates from. For instance, as easterly wind means that the wind is coming from the east, not moving east. The wind travels horizontally across the earth and is measured on the surface using wind vanes and in the upper atmosphere using aircraft reports, among other means to measure this. Put simply, the Coriolis effect makes things like planes or currents of air traveling long distance around Earth appear to move at a curve as opposed to a straight line. The Coriolis effect describes the pattern of deflection taken by objects not firmly connected to the ground as they travel long distances around and above Earth. The Coriolis effect is responsible for many large-scale weather patterns. The key to the Coriolis effect lies in the Earth's rotation. Specifically, the Earth rotates faster at the equator than it does at the poles. Earth is wider at the equator, so to make a rotation in one 24-hour period, equatorial regions race nearly 1,674 kilometers per hour. Near the poles, the Earth rotates at a sluggish 0.0008 kilometers per hour. So to put things in perspective, let's pretend that you're standing at the equator and you want to throw a ball to your friend in the middle of North America. If you throw the ball in a straight line, it will appear to land on the right of your friend because he's moving slower and has not quite caught up. But now pretend you're standing at the North Pole. When you throw the ball to your friend, it will appear again to land on the right of him. But this time it's because he's moving faster than you are and has moved ahead of the ball. Everywhere you play global scale quote-unquote catch in the northern hemisphere, the ball will always deflect to the right due to the Coriolis effect. This apparent deflection is the Coriolis effect. Fluids traveling across large areas, such as air currents, are like the path of a ball. They appear to bend to the right in the northern hemisphere. The Coriolis effect behaves the opposite way in the southern hemisphere, where currents tend to bend to the left. The impact of the Coriolis effect is dependent on velocity. The velocity of the Earth and the velocity of the object or fluid being deflected by the Coriolis effect. The impact of the Coriolis effect is the most significant with high speeds and long distances. Why does air rise and descend? Hot air is less dense than cold air, which is why hot air rises and the cold air sinks. Hot and cold air currents power the weather systems on Earth. The sun plays a major role in heating the planet, which also creates hot and cold air energy systems. Warm air currents typically bring rain because they form over oceans. That's why hurricanes and tropical storms form at sea and eventually move towards land. Warm air moves up into upper layers of the atmosphere where the cold air sinks down into lower levels. As hot air from the Earth's surface rises, it soon becomes cold air as it nears space. As hot air cools, it sinks back to the surface of Earth, where it gets warmed by the ocean only to rise once again. This is called a convection current. Convection currents are defined as room air rising and cold air sinking. Prevailing winds influence the climate of a region because they bring in weather from the upwind area. The position of a region relative to the circulation cells and wind belts has a great effect on its climate. In an area where the air is mostly rising or sinking, there isn't much wind. At about 30 degrees north and 30 degrees south, the air is fairly warm and dry because much of it has come from the equator where it has lost most of its moisture. At this location, the air is descending, and sinking air warms and causes evaporation. Winds that blow from the sea often bring rain to the coast and dry weather to inland areas. Winds that blow east from warm inland areas such as Africa will be warm and dry. Winds that blow to, like Britain, from inland areas such as Central Europe will be cold and dry in winter. Prevailing winds come from a southwesterly direction over the Atlantic. These winds are cool in the summer, mild in the winter, and tend to bring wet weather.